Okay, in the mean, median, and mode lesson, we're going to talk about different averages. In the mean, median, mode are three kinds of averages. There are lots of different averages in statistics, but these are the three most common. The mean is basically the average that you're most familiar with, where you sum up all the values in your data set, and then you divide by the number of values. So the mean is going to be the sum of all the data values divided by the number of values. Now, there's a formula for this. If you're talking about a sample mean, the symbol for the mean is X with the bar over it, and you say that as X bar. Now, so that means you're not talking about the whole population. So let's say you're doing a study on something and you don't have access to the entire population, so you take a sample of that population, and then from that data that you collected from your sample, you use that data to calculate the mean. That's the sample mean. It's the mean that you calculated from a sample. The population mean the symbol for that is a fancy M, and you say it as mu. So this is if you had access to the entire population and you find the mean of everybody in the population. To find the sample mean, you add up all your data values. X represents your data values, and this little funny Greek symbol is sigma, and that means add up all the X's, add up all your data values, and then you divide by N, which is the number of data values in your sample. For mu, if you're calculating the mean of the entire population, you add up all your data values and then you divide by what we use, a capital N. The median is basically if you list your data in increasing order, your median is going to be the center value. Okay, so this may vary slightly on how you find the median depending on if you have an odd set of data or an even set of data. If you have an odd set of data, so let's say you have 7 data values, that's an odd set of data. The middle value is going to be in the position of n plus 1 over 2. So say, for example, you have 7 data values, so n is going to be 7. So it takes 7 plus 1 is 8 divided by 2, which would be 4. So the fourth data value from the beginning of your data set, and you move in increasing order, the fourth position would be your center value, which would be your median. If you have an even set of data, the middle value is going to be the mean of the two center values. And this will all make a little bit more sense once we go through some examples. The mode is going to be the data value that occurs the most. Now, with the mode, we're going to make 2 notes. Not all data sets have a mode. And then a data set, the second note is a data set can have more than one mode. So these are a couple of special cases. Now for the weighted average, if you have X as your data values, your variable, and your W is the weight. Your weighted average is going to look like this. You're going to take the sum of each data value times its weight and divide it by the sum of all the weights. And again, this is going to make more sense after we do an example. So the first example, we're going to find the mean, median, and mode of this data set. So the first thing we want to do is we want to find the value of n. How many data values do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means we have an odd data set. When I list it in order, I have 13, 13, 13, 13. Then we have 14, 14, 16, 18, and 21. When we list it in order from smallest to largest. Now, because n is odd, to find the center value, you take n plus 1 divided by 2. So that's 10 over 2, which is 5. Because n is 9, I have 9 plus 1 is 10, divided by 2 is 5. So that means my median, after this is ordered from smallest to largest, my median is going to be in the 5th position. Here's the 1st, 2nd, 3rd, 4th, and 5th. So here's my median. It's the center value. And if you look, I have 4 values on this side and 4 values on this side. So this is truly the center value. So we have the median is 4. Okay, now for the mode. The mode is the value that occurs the most. If you look, 13 occurs 4 times. No other number does that. 13 is the number that occurs the most in this data set. So the mode is 13. For the mean, that's going to be the sum of all our data values, and then we divide by the number of data values. If I add up all these data values, 13 plus 13 plus 13 plus 13 plus 14, and I keep on going, if I add all those up, I get 135, and then if I divide by 9, I get 15. So my mean is going to be 15. There's a way I can show you how to do this on the calculator. I'm going to go into Stat and into Edit because I want to enter this data in my list. Since I already have data values in there, I'm going to highlight L1 and hit Clear Enter. That way it will clear out my list. And then I'm going to enter all my data values. So I have 13, 13, 13, 13. Then I have 14, 14. 16, 18, and 21. Okay, once you enter in all your data values, what you're going to do, notice that I put this in L1, that's my first list. I'm going to hit the Stat button again. This time, up across the top, I have 3 menus. I have Edit, Calc, and Tests. I'm going to use my right arrow to arrow over to Calc. I'm going to choose option number 1, 1 variable stack. So now I'm going to hit Enter. And then because I want to do this on my list 1, I'm going to make sure I tell the calculator by hitting second 1 to choose L1 above my 1 button. I'm going to choose L1 and say perform this on my list 1. That's where I have all my data. And then I'm going to hit Enter. Now, when you look at this right here, the X bar, that's your mean. And that's what we got. If you notice here, that's my mean. If you scroll down a little bit, you'll see MED. The MED stands for median. And you'll see that the median is 14. Oops, I noticed I forgot my 1 there. There's my median, it's 14. So the calculator can check your arithmetic for you. Okay, for the second example, let's see, I have 1, 2, 3, 4, 5, 6. And it's 6 here. I have 6 data values. So that's an example of when we have an even number of data values. So the first thing I'm going to do is order this from smallest to largest. So I have 1, 2, 3, 5, 6, 7. And don't forget, if you have a large data set, the calculator will do that for you. If you just enter in your data and then you go to calculate and you choose sort ascending, it will order it for you. This data set is small enough that we can do it by hand. Okay, so to find our center value, when we have an even set, we take n plus 1 divided by 2. Since n is 6, I have 6 plus 1, which is 7 divided by 2, which is 3.5. So I know that with an even set, I'm going to have 2 middle values. And since this tells me the middle position is 3.5, I know my 2 middle positions are 3 and 4. The third and fourth position, because 3.5 is between 3 and 4, I know the 2 middle positions are 3 and 4. So if I count 1, 2, 3, here's the third position, 4, here's the fourth position. So these are the 2 middle positions. So I have 2 on this side, 2 on this side. Because this is an even data set, an even number of values, I have to take the mean of the 2 center values. So that's going to be 3 plus 5 divided by 2. So this is going to be my median. It's the mean of the 2 center values if you're looking at an even set. All right, now to find the mean, I take the sum of all my data values and divide by the number of values I have. If I add up all these values, if I take 1 plus 2 plus 3 plus 5 plus 6 plus 7, if I add those up, I get 24. And then if I divide by 6, because I have 6 data values, that gives me 4. So this is my X bar, or my mean, for this data set. Here's my median. Okay, lastly, we're looking for the mode. The mode is the value that occurs the most. Each one of these data values only occurs one time. There isn't one that occurs more than another. So in this case, this is a special case where we have no mode. Okay, in example 3, we're going to find the mean, median, and mode again. If you notice, this is already in order for us from smallest to largest, so that makes it nice. We have 10 data values here, so n is 10. That means it's an even data set, which means when I find the median, it's got to be the mean of the 2 center values. So to find the center values, I've got to take n plus 1 divided by 2, n plus 1, that's 10 plus 1, which is 11 over 2, which is going to give me 5.5. Since 5.5 falls between 5 and 6, these are going to be my 2 center positions. So, since it's already in order, I'm going to count over to the 5th and 6th position. So I have 1, 2, 3, 4, 5. Here's the 5th position. Here's the 6th position. So I have 4 on this side and 4 on this side. So these are the 2 center values. Now I have to take, to find the median, I need to take the mean of those 2. So 10 plus 11 divided by 2. When I do that, I'm going to get 10.5. So my median is 10.5. And again, you can check this on your calculator because I just showed you how to do that. Okay, 4, let's see, the mode. If you notice, 10 occurs 3 times and 11 occurs 3 times. So those are the two data values that occur the most. So in this case, I have 2 modes. Now for the mean, we're going to add up all the data values and then divide by the number of data values. If I add up 8 plus 9 plus 10 and I keep going and I add all those up, I'm going to get 105. And then I'm going to divide by 10 because there's 10 data values. And then that's going to give me 10.5. So my mean is 10.5. Okay, for the weighted average example, it says in your biology class, your final grade is based on several things. You have a lab score, so I'm going to write that down, lab score. You have 2 tests, so we'll label that as test 1 and test 2. And then you have a final exam. There are 100 points available for each score. However, the lab score is worth 22% of your grade. So now we're going to write down the weights. For the lab, that's worth 22% of your grade. For the first test and the second test, it says here that each of those is worth 20.5%. And then it says your final exam is worth 37% of your grade. We're going to compute the weighted average for the following scores. You got a 65 on your lab, 65 out of 100. You got a 90 on the first test. You got a 67 on the second test, and then you got a 99 on the final exam. So these are your X's. Those are your values for your data, and then these are your weights. Now because when we do arithmetic we want to work in decimal form, I'm going to change my weights to 0.22 into decimal form. 0.205, 0.205, and then 0.37. Now our formula for weighted average says I take each of those data values and multiply it by its weight, and then this tells me to add it all up. Then I divide that answer by the sum of all my weights. So I'm going to take each data value, these are my data values, so those are my scores, and I'm going to multiply them by their corresponding weights, and then I'm going to add them all up. So I take 65 times 0.22 plus 90 times 0.205 plus 67 times 0.205 plus 99 times 0.37. I'm going to add all that up, and then I'm going to divide by the sum of all the weights. So that's 0.22 plus 0.205 plus 0.205 plus 0.37. Okay, when I take 65 times 0.22, I get 14.3. When I take 90 times 0.205, I get 18.45. When I take 67 times 0.205, I get 13.735. And then when I take 99 times 0.37, I get 36.63. And then I'm going to divide that by all my weights added up. So 0.22 plus 0.205 plus 0.205 plus 37. That totals to 1. Then I'm going to add all these up and divide by 1. And I'm going to get a final answer of 83.115. So this would be your final grade in the class, 83% approximately. Okay, now we're going to talk about trimmed means. We're going to compute the mean and median of the entire sample. Let's do this on the calculator to practice. So I want to put my data values in my list 1. I'm going to clear out what I already have in there. So I highlight L1 and hit clear, enter. Okay, once you have all your data values in there, we're going to compute the mean and the median of the entire sample by hitting the stat button. And I'm going to arrow over to calculate. And I'm going to choose one variable stacks. And I'm going to tell the calculator that I put this in list 1 by hitting second and then 1. So here are my variable stacks for our new data set. X bar, which is my mean, that came out to be 35.95. And then the median, let's see what the median came out to be. If I scroll down and I look for MED, the median came out to be 32.5. Okay, now we're going to talk about a 5% trimmed mean for the sample. What we're going to do is we're going to calculate a new mean from this data set if we take off some of those values. And what we mean by 5% trimmed is we're going to take 5% from the lowest value and 5% from the highest value. The reason why we do this is if we have an outlier that might skew our distribution, we want to get a more accurate picture of what's going on and take that outlier out so that the mean is more accurate and closer to the median. Okay, so computing a 5% trimmed means we're going to take 5% off the top, the highest value, and then 5% from the lowest. So first we need to find out what that 5% is. How many data values would be 5%? Since we have 20 values in our data set, I want to find 5% of 20. And to do that, I change 5% into a decimal times 20. If I take 0.05 times 20, that gives me 1. So that means I'm going to take one data value from the lowest value and one from the highest value. So that means we're going to knock off this 14 and this 80. We're going to delete that off of our data set. And then we're going to recalculate the mean without those values. If for some reason this number didn't come out to a whole number, then you would just round to the nearest integer. Okay, so we're going to take one off the top, one off the bottom. So when I calculate our new mean and median without those two values in there, I'm going to go back to stat and edit. I want to delete the 14, so I'm going to hit delete on 14, and then I want to take off that last value, which is 80. So that's going to leave us with 18 data values. Now I'm going to go back and recalculate the mean and the median. So I hit the stat button, I go over to calculate, and I do one variable stacks, and I want to tell it to do it for L1, and then I'm going to hit enter. So our new mean is 34.7. This is for the trimmed mean. Let's look to see what happened to our median. If we scroll down and look at the median, our median is 32.5. Notice that our median didn't change. Why didn't our median change? Well, just because we knocked off the lowest value and the highest value, the median, remember, is the center value. 32.5 would still be in the center if we knock off one on the top and one on the bottom. Also notice, let me scroll back up, also notice that when we trim off the lowest and the highest value, my mean and my median are closer together. These are further apart when we add those lowest and highest values in there. And then when we take them off, the mean and the median get closer together. The median stays the same. And also, the median and the mean are closer in value with the trimmed data set. Okay. Now, when we talk about measures of center, what we mean is a value that describes the data by summing it up in one value. So it's a way for us to give a representative or a typical value in the data set. Now, there are 3 commonly used measures of center. We have the mean, median, and mode. The mean is the average that we're probably the most familiar with, which is where you add up all the data values and then you divide by the number of values that you have in the set. And the notation for this will either look like this if it's a sample mean, or it will look like this, which is kind of like a cursive M, and that would be for the population mean. And the way that you pronounce that M, I'll put it in quotations here, it's pronounced mu. Now, you might see more notation on how you actually calculate the mean. If you see this symbol, this is sigma, and that is just a symbol for sum, which means add up all the values. So you might see the mean described using an equation, which will look like this. You'll have the sum, and then it might look something like this, where xi represents all the data values, and then you divide by n, which is the number of data values. So this is just a fancy formula for saying the same thing that I said up here in words. This means add up all the data values, and then this means divide by the number of values you have in your set. Now, the median is another way to measure the center, and this is something that we've already talked about as well. The median is the 50th percentile, or another way to say that is Q2, the second quartile. And that is the value that when you list your data set in increasing order from smallest to largest, it's going to be the middle value. And that's going to cut the data in half. So there will be 50% of the data on the right of the value and 50% of the data will be on the left of that data value. And that, again, only works if the data is in order from left to right. Now, one value that we have not talked about yet is the mode, and you've probably heard of this before, but let's do a quick refresher. The mode is the value in the data set that occurs the most, or you can say the most frequently. Now, there are special cases where you would have no mode, or you can have more than one mode. Let's go through a couple quick examples. So if I gave you a data set that looked like this, in this case, the mode would be 3, because that is the data value that occurs the most. In this next example, let's say I give you this. All of the data values are written the same number of times. So we don't have any one data value that repeats more than another data value in the set. So this is a special case where we would say we have no mode. And then the last special case is when you can have more than one mode. So let's say I gave you this data set. So I have all of this listed out. I see that 1 and 4 both occur a lot compared to the other data values, but they both occur the same number of times. So in this case, I would say we have 2 modes. We would have 1 and 4. Usually you get this case where you have 1 mode, but these are special cases that can happen. Okay, let's go through our first example here. It says, AIDS data indicating the number of months a patient with AIDS lives after taking a new antibody drug are as follows. And it's listed it here for us from smallest to largest, which is nice. And we have to calculate the mean and the median. So the mean would be if I take all of those data values, so I'll label these are my XIs, and I add them up, and then I divide by the number of values that we have, which in this case is 40. I'll let you guys do that on your own. I'm not going to waste time doing that in the video, but I'm sure you can add up all those values. It just takes a little bit of time. When you add all of those up and you divide by 40, you should get 23.6. All right, now for the median, since we have 40 data values, our N is 40. Since we're looking for the median, that's our 50th percentile, so my K is going to be 50. And I'm going to use our formula for finding percentiles. So I'm going to take 50 over 100, and I'm going to multiply it by 41. And I'm multiplying it by 41 because if you remember in our formula, in the previous section, what goes in those parentheses is n plus 1. And in this case, our n is 40, so I'm going to add 1. So when I find this value, I'm going to get 20.5, which means I need to take the average of the 20th and the 21st position. So when I count from smallest to largest up, and I find the 20th and the 21st position, that is going to be, let's write this down, in the 20th position, that's going to be 24, and then the 21st position is also 24. So when I find the average, I have 24 plus 24 divided by 2, and that's going to give me 24. So this is going to be our median. Now let's practice finding this on the calculator to check our work. Okay, let's go ahead and work through finding the mean and the median on your calculator. Now, when you have a large data set, it's definitely easier to do it on the calculator. But if you have a smaller data set, by the time you enter everything in, it's probably easier to just do it by hand. But it doesn't matter to me which way you do it. I'm showing you both ways so that you can choose which way you want to do it. So you want to first hit the Stat button and go to your Edit option so you can edit your data list. Choose a list. It doesn't matter which one. Pick one and enter your data values. Just make sure you pay attention to which list you're putting the data values in so you can tell the calculator the correct list later. So go ahead and pause the video, put your values in, and then unpause. Once you have your data values in there, what you want to do is you want to hit the Stat button again. But this time you want to arrow over to Calculate, the same place where you go to get your 5-number summary. You want to access option number 1 variable stacks, hit Enter. Tell the calculator which list you want to perform the 1 variable stacks with. So I have my data values in list 1, so I want to make sure this says list 1. And then I'm going to tell the calculator to calculate. I'm going to hit Enter. And then it's going to give me a whole bunch of values here. Now we've done this before with 5-number summary, and the 5-number summary is down here, right underneath where your N is. N equals 40, that tells me how many data values I have. And then here's my 5-number summary. If you remember, the median is one of the values in your 5-number summary. So here's our median here, 24, and that's what we got when we calculated it by hand. Now to find your mean, that's actually the top value right here. That's your X bar. And when we did it by hand, we got 23.6. The calculator got 23.575, but I rounded to 1 decimal place. This value here, where it has the sum of the X's, this is where the calculator adds up all of your data values in your list. So if you take 943, which is the sum of all those data values, and you divide by 40, that's where the calculator is coming up with the 23.575. So in the next example, we're going to talk about how one average better describes a data set than another, and it's better sometimes to use one value over another. When we use the word mean, sometimes that's used interchangeably with the word average. But what is important to understand that the mean is a kind of average, and so is the median, and so is the mode. The word average describes, in general, the measures that you can use to describe the center of the data. When we talk about a specific kind of average, that's when you use the word mean, median, or mode, because that describes how that average is calculated. So mean, median, and mode all fall under that umbrella of average. So it's not necessarily always the right thing to do to use the word mean interchangeably with the word average. So there are times when using one of those values over another gives us a better understanding of the data. And this example is one of those times. So in this example, what we want to do is we would rather use the median in this case rather than the mean, because in this example, it talks about a town. It's a small town, 50 people. One person earns, in the whole town, one person earns $5 million. So this guy has this awesome job. He's making lots of money. But the other 49 people each earn about $30,000. So when we want to use an average to describe the salary of the people in that town, if I use the mean, that means I would add up all of the data values and divide by 50, since there's 50 people. Well, there's 49 of the 30,000s, so I would add 30,000 49 times. And then I would add in the 5 million. When I find that average, I'm going to get 129,400 for their yearly salary. Because that 5 million is thrown in there, it's throwing the mean way off. If I look at the median, which is that center value, when we order it from smallest to largest, we're going to get 30,000, right? Because we're going to have 30,000, 30,000, 30,000, 49 times in a row. And then at the very end, we add on that 5 million. That's the highest value. So the middle value is going to be 30,000. Now, of these Now, of these two values, this 30,000 does a better job of describing the overall salary in this town. So this is one of those cases where it's better to use the median to describe the data than the mean. So keep that in mind as we are going through the course, that sometimes one is better to use over the other. Okay, now for this example, we're going to find the mode. There really isn't a way to find the mode on the calculator where the calculator just gives you what the mode value is. However, the calculator can help you find the mode if you have a large data set. If you have a very large data set, I would suggest that you put your values into your list and sort them from smallest to largest, because once they're sorted, it's easy to spot which value appears the most. If you have a smaller data set, then usually it's easier to just eyeball it. Like in this case, the data set is small enough that when I look at it, I can see that 72 occurs 5 times here. I don't see any other data value that occurs more than 5 times. So this one is easy to just eyeball it. So I would say in this case, the mode is 72. So looking at this next example, we have a frequency chart here with statistic test grades, and we have our grade intervals here on the left, and then the frequency on the right where it's listed as number of students. Now, if I wanted to find the mean of this class using the information in the chart, it's impossible to find the exact mean because the data values are grouped in these intervals and we don't know what the individual grades are. I just know that there's one grade that falls between 50 and 56.5. I know that there are 4 grades that fall between 62.5 and 68.5. So it's impossible, since we don't have those individual data values, to find the exact mean. So we're going to use a process that we can estimate the mean, and we're going to do that by finding the midpoints. So let me organize this here real quick. And we talked about how to find a midpoint in a previous section, but just a quick refresher. If you forget how to do that, you take and add the lower bound, you add the upper bound, and then you divide by 2. That will give you the midpoint. So in this first interval, my lower bound is 50, my upper bound is 56.5. I'm going to add those together and divide by 2, and I'm going to get that the midpoint is 53.25. And then I'm just going to do that for each of these intervals. On the second interval, I'm going to get 59.5. On the third interval, I'm going to get 65.5, then 71.5, 77.5, 83.5, 89.5, and then 95.5. So these are all my midpoints. Then what we're going to do, actually, I need to erase this so I have more room. Let me put that somewhere else. I'll put it over here. The midpoint is the upper plus the lower divided by 2. Okay, now what we're going to do is we're going to take each of these midpoints and multiply by the frequency, because I know that I'm going to have one number that's around 53.25. I want to make sure when I take my mean that I add in a 53.25. So I'm going to take 53.25 times 1. That gives me 53.25. So I'm going to take, in this column, this is my midpoint times my frequency. All right, now I'm going to take my number of students in the second class and multiply by 59.5. Well, there's no grades on that interval, so this is just going to be 0. For the next interval, I know I have 4 grades that are around 65.5, so I'm going to find out what that is. So I'm going to take 65 1.5 times 4, that's going to give me 262. Then in the next class, I have 4 grades that are around 71.5. That's going to give me a total of 286. I know I have 2 grades that are around 77.5. So that's going to give me 155. I have 3 grades that are around 83.5. So that's going to give me 250.5. I have 4 grades that are around 89.5. That's going to give me 358. And then lastly, I have 1 grade that is around 95.5. So I'm going to take 95.5, multiply by 1. Okay, now that I've taken all the midpoints times the frequencies, now I'm going to add this up. When you add that up, you should get 1,460.25. Now the last step is you want to divide by the number of values that you have. I had 1 value here, 4 here, 4 here, 2, 3, 4, and then 1. That gives me a total of 19. So I'm going to take 1460.25 and divide by 19. And that's going to give me my estimated average, which is going to be 76.86. So we use the midpoints of these intervals to estimate the scores in each interval. And then we just took the average as we normally would. So keep in mind, again, this is just an estimate since we don't know the exact values that are on these intervals. Okay, last example is about the weighted mean, which is very similar to what we just did. So when we talk about a weighted mean, it's a kind of average that instead of each data point contributing equally to the mean, each of those data points contribute different values or different weights than others. So when all the weights are equal, if all the points contribute an equal weight, then that's just the regular mean that we always use. And sometimes it's even called the arithmetic mean. But when some points are worth more than others and they have different weights, that's called the weighted mean. And here's our fancy formula for that. And all this means is all your x values represent your data values. So x1 is the first data value, x2 is the second data value, etc. And then the w's are the corresponding weights. So when you see w1 or w2, w1 is the weight for the point x1, w2 is the weight for x2, etc. So then you add up all of those products and then you divide by the total weight. And remember, that's what that symbol means, is we're going to add them all up. So this is saying we're going to multiply each weight times each value of x and add it up. And then we're going to divide by the sum of all the weights. That's what those fancy symbols mean. Okay, so let's walk through an example. A perfect example of somewhere you would see a weighted average is when you compute your GPA. When you take a 5 credit hour course, that's going to be weighted in your GPA heavier than if you take a 1 credit hour course. Each of those grades that you get for those classes, since you have different credit hours in each of those classes, they're not contributing equally to the average. So let me write this down. So my x's, I'm going to make a chart here. My x's are my data values, or my grades, 3.7, 1.9, 2.8, and 3.3. The corresponding weights would be 5, 3, 5, 5. So what we need to do then is find the products. So we're going to multiply each of the weights times the corresponding x value. And then we're going to total them up and divide by the total number of credit hours, which is what your weights are. All right, so when I take 3.7 times 5, that's going to give me 18.5. When I take 1.9 times 3, that's going to give me 5.7. When I take 2.8 times 5, that's going to give me 14. And when I take 3.3 times 5, that's going to give me 16.5. All right, now I am going to add up all those values. So I'm looking at the total of my WX's, which can be written like this. I'm going to add up the sum of all my WX's. When I add those all up, I get 54.7. When I add up all my weights, those are my credit hours, all my W's, I get 18. So to find the GPA, I'm going to take the sum of all my products, which we said is 54.7, and I'm going to divide by the sum of my W's, which is 18. When I do that, and it says to round to 2 decimal places, when you do that, you get 3.0388, and then when we round to 2 decimal places, that gives me 3.04. So there's the GPA calculated for this semester with these grades. So looking ahead to the next section, we're going to use our understanding of the measures of center to start talking about the shapes of different data sets. So when we talk about measures of the location of data, these measures tell us a position of a single data value in relation to the other values in that data set. And that data set can be either a sample or a population data set. So when you're given a value that tells you the location in the data set, when the data set is sorted from smallest to largest, that is a measure of the location of the data. Now, there's different terms for that for different positions, and all of these fall under the umbrella of percentiles. So percentiles is just the value in a data set for which a percentage of data falls below that. Or you can say less than that value. So if you imagine that you list all your data values in order, and sometimes you could have repeats, but for a visual effect here, imagine that you have a bunch of data values and you list them in order from smallest to largest. So these dots represent my data values listed smallest to largest. And I said I want to find the 10th percentile. The 10th percentile would be whatever that data value is that separates the data value so that 10% lies below, that's the key idea here, and 90% is above. So this is an example of the 10th percentile. So that's in general what a percentile is. Now we have specific percentiles. We have the median. The median is the 50th percentile. So this is the value in the data set that splits the data so that 50% falls below and 50% falls above. If you imagine this line and you're listing out all your data values, if I were to split the data set in half, that would be the median, where 50% of those data values lie below and 50 above. Now also keep in mind, because this can kind of throw you for a loop here, the median doesn't necessarily have to lie in the middle of the data set in terms of distance on the number line. So in other words, I could have a whole bunch of data values that are really small numbers that are all clustered here when I list them in order, and then I could have a couple of large ones here. But when I find the median is somewhere over here. It's not halfway distance-wise or geometrically. If we look at this, it's not going to split it up so that it's symmetric on each side. We could still have 50% of the data over here and 50% of the data on the right, because we're not looking at the distance of the data, we're looking at the number of data values. So you could have 10 data values here. I didn't count these dots, I'm just saying for example. You could have 10 data values over here on this side and then 10 data values on this side, but it not necessarily be the halfway point from the minimum to the maximum value. So just keep that in mind. The quartiles split the data values up into quarters. So we have notation that looks like this, which represents quartile 1, which is also the same thing as saying the 25th percentile. Then we have Q2, which is also known as the median. These are all different ways of saying the same thing, which we just talked about is the 50th percentile. Then we have Q3, which is the third quartile, and that represents the 75th percentile. So again, if we imagine that this number line represents our data, and then I find the values that split the data into quarters. Let's say my Q1 is here. Let's say my median is here. And let's say my Q3 is here. Keep in mind, please, that I did not count these dots. This is just a quick picture to show you what this looks like. All right, so when I find those values, whatever the value is for Q1, that means 25% of the data falls below that value. When I look at the median, I know that 50% of the data falls to the left of the median. And for Q3, that's 75% of the data falls to the left of Q3. Now, when I take Q1, Q2, and Q3, or you can call it Q1, the median, and Q3, and I add in the minimum value and the maximum value of that data set, that's what's called the 5-number summary. That's the values minimum. Then you have your Q1, your Q2 or your median, your Q3, and then your maximum value. So if I add in on that number line, my minimum value and then my maximum value of that data set, all of these numbers here, the minimum, Q1, medium, Q3, and the maximum, those represent what's called the 5-number summary. Now, when I look at the center values of that between Q1 and Q3, Q1 to Q3, that's going to be the middle 50% of the data. And when you find the range of that, that's what's known as the interquartile range. So I for inter, Q for quartile, and R for range. And so that's just the difference between your Q3 and your Q1. Okay, let's walk through the first example. We have in this data set 11 values, and they're already listed in order for us. But if they aren't listed in order, that's not that hard to do if it's a small data set. And if it's a larger data set, in one of the previous lessons, I did show you how to sort data values on the calculator, so you could use that sorting feature if you need to. So for this first example, we're going to practice finding the 5 5-number summary. And remember the 5-number summary, that's the minimum value, our Q1, which is our 25th percentile, our Q2, which is our median, our Q3, which is our 75th percentile, and then the maximum value of the data set. Now, because in this case the data set's already sorted for us, it's very easy to spot the minimum and the maximum value. The minimum is 1 and the maximum value is 27. But we have a little bit of work to do to find Q1, Q2, and Q3. So to find Q1, we know that that's our 25th percentile. So when we use our formula, we're going to put in K is 25. And since we have 11 data values in this data set, N is going to be 11. So when I go to put this in to find the position in my data set in which the 25th percentile lies, I'm going to put in 25 over 100, and I'm going to multiply that by 12 because in our formula we take whatever N is and we add 1. So this is our N plus 1. Okay, when we do that, we're going to get 3. So that means in this data set, my Q1, or my 25th percentile, is the 3rd value when it's in order. It's in the 3rd position. So this is the 1st position, 2nd position, 3rd position. So that means my Q1 is going to be the data value 5. So you can see how it can get confusing. The I tells you the position of the data value that we're looking for. So the 3 isn't the data value itself, it's the position. So you still have to go up to the data set and find that value. Okay, so let's find Q2. That's the median, or as we know it, the 50th percentile. So in this case, because we're looking for the 50th percentile, K is going to be 50, and we're using the same data set. I still have a data set with 11 values in it. So when I try to find the position for the 50th percentile, I'm going to take 50, which is my K, divide by 100, and then multiply by 12. That's going to give me 6. So my median is going to be in the 6th position when I count over. So 1, 2, 3, 4, 5, 6. So my median is 9, which means that splits the data in half. So half the data is to the left and half the data is to the right. So I'm going to put down that my Q2 is 9. Now let's do Q3. Q3 is the 75th percentile, which means when I use my formula, K is going to be 75, N is still 11 because I'm using the same data set. And so when I go to find my position, I'm going to take I is equal to 75 over 100 times 12. And that's going to give me 9. So my Q3 is going to be in the 9th position. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So my Q3 is going to be 18. So that tells me that 75% of the data falls to the left, or is less than 18. Now, in this example, the value for the position came out to be a whole number. If it came out to be a partial number, like 3.5, then what you want to do is you want to find the average of the two values that fall on either side of the position for 3.5. So, for example, let's say the position came out to be 3.5. Then that means that 3.5 is between the third and the fourth position. And if that happens, you take the average of the third and the fourth position. Whatever those values are in those positions, you find the average, and that will be the percentile that you're looking for. Okay, the next example says we have two data sets. Test scores for college statistics class held during the day are, so this is the day scores, and then these are the night scores. We want to find the interquartile range and then compare them for each data set. The first thing we need to do is sort each data set, because then once we sort it, we can find the value of Q3 and Q1, because to find the interquartile range, we need to know whatever Q3 is and then subtract my value for Q1. So go ahead and pause the video for a minute, and in list 1 of your calculator, sort this data, and then in list 2, sort the data for the night class, and then we'll find our Q3 and Q1. So at this point, you should have your data values put into your list 1 and your list 2. If you forget how to do that, you go hit the stat button here. You choose edit, and then you can put the first set of data, which is the test scores for the day statistics class. And then L2, you enter in your data values for your night statistics class. And I've already done that. Now to sort it, to make sure it goes from smallest to largest, we're gonna go back to stat. I'm gonna tell it to sort A. Sort ascending means it's gonna go from smallest to largest, and I'm gonna do that for both of my lists. So now I'm gonna do the same thing for my list 2. If you forget where your list buttons are located, that would be above your 1 and your 2 button. So you have to hit the second button first. After you tell it to sort, the calculator will say that it's done. And so now when we go back to our calculator, we will see that everything is listed in order. So my L1 is all sorted and my L2 is all sorted. So now that we have sorted the data, let's use our formula to find Q1 and Q3 for each data set. So for the first data set, if we look for Q1, that would be the 25th percentile, which means in my formula, I'm going to put 25 over 100 times, and this is going to be times 21, because in the first data set I have 20 data values. So let me make a note of that over here to the side. N is 20 in the first data set, and K in this case will be 25 because we're looking for the 25th percentile. Okay, so we're going to put that in on our calculators, and we're going to find that this is going to give us 5.25. So this is the case where it doesn't fall to a specific position. It's going to fall between two positions. So I want to find the average of the 5th and the 6th position. And this will give me the Q1. And I know it's going to be the average of the 5th and 6th because 5.25 falls between 5 and 6. So when I go and I look at my list 1 and I go down and look at my 5th position, My fifth number in the list is 56. My sixth number in my sorted list is going to be also 56. So when I average these two together, I'm going to get that Q1 is 56. Now let's look for Q3. And we're still doing this for list 1. That's the 75th percentile. So in this case, N is going to be 20 because I'm still doing this with list 1, and K is going to be 75. So I'm going to take 75 over 100, times it by 21. That's going to give me 15.75. So for Q3, I have to average the 15th and the 16th position together, because 15.75 falls between 15 and 16. So I'm going to find on my list, we're still looking at list 1, I'm going to scroll down and find the 15th and the 16th position. The 15th position is 81, and the 16th position is 84. So I'm going to find the average of 81 and 84. When I do that, so I'm going to take 81 plus 84 and divide by 2. When I do that, I'm going to get 82.5. So this is my Q3, here's my Q1. So my interquartile range for list 1 is going to be my Q3 minus my Q1, which is 82.5 minus 56, which is going to give me 26.5. So there's my interquartile range. Now, following that same procedure for list 2, you should get an interquartile range of 11 for list 2. So try that on your own and make sure you can get it. And if you can't, let me know and I'll help you with it in class. Now we're supposed to compare these. If I look at the interquartile range for the first list, for the daytime classes, there's a much bigger range of values because that 26.5 says there's a bigger space in between Q3 and Q1. Whereas the space between Q1 and Q3 for the second list, or for our night classes, that's going to be 11. So this suggests that there's going to be more variation in the first data set, which is for the day classes, than there is for the evening classes. In part B of this example, we are looking for any outliers in either of the two sets. In general, an outlier is going to be any data value that falls way above or way below the majority of the data values. And usually you can spot it pretty quickly when you're looking at a data set, if it's a small enough data set. So for example, if we had a list of test scores and the majority of the test scores were in the 60s, 70s, and 80s, and then you spot one test score that is, say, a 21, that test score of 21 lies way below the majority of the data value. So that would be considered an outlier. But if you're not sure, there's a formula you can use to check to see if you have a data value that is way below any other data values in the set. You can take your value of Q1 and multiply it by your interquartile range times 1.5. And then if you want to look to see if you have any data values that are way bigger than your other data values, you can find your Q3 and add your interquartile range times 1.5. So we're going to do this and check to see if there's any outliers in any of those two data sets. So for the first data set, which we put in list 1, we're going to take our Q1, which is 56, and we're going to subtract our interquartile range, which was 26.5, and multiply that by 1.5. Using order of operations, don't forget you need to do this first, 26.5 times 1.5 first, and then subtract from 56. When you do that, you get 16.25. So what we want to do is look to see if there's any data values in list 1 that lies below 16.25. And if it is, it would be considered an outlier. Then to check to see if there's an outlier that's larger than all the other data values, you want to take your Q3. We're still looking at L1. So my Q3 for L1 was 82.5. I'm going to subtract my interquartile range times 1.5, which would be 26.5 times 1.5. Don't forget order of operations. You need to do this first. When we do that, whoops, this should be plus. So I'm going to take 82.5 plus 26.5 times 1.5. And when we do that, we get 122.25. So if there's anything below 16.25 or anything above 122.25, that's going to be considered an outlier. Now, when we look at that first data set up at the top here, I don't see any data values that fit that description. So for list 1, I'm going to put down that there are no outliers. Now for list 2, we're going to take and find Q1 that we got for list 2. And when you did that on your own and checked it with my answers, you should have gotten that your Q1 was 78. And when we subtract that from our interquartile range times 1.5, you should get 61.5. Now for L2, for your Q3, you should have gotten 89. And when you add that to 11 times 1.5, you should get 105.5. So we're looking to see if there's anything that lies below 61.5 or above 105.5. And that will tell us if there's an outlier. It looks like in this case, we're going to have 2 outliers. We have 45 and we have 25.5. Those are the 2 that are on the low end. So those are much lower than all the other scores. Now on the higher end, because we found using that rule that anything over 105.5 would be considered an outlier on the higher end, I don't see any values that are above 105.5 here. So no outliers that are on the high end for list 2. So I am going to put down, there's outliers, 45 and 25.5 for that second list, but they're both lower values. All right, in this next example, we're given a frequency chart, and it says that there are 50 statistics students that were asked how much sleep they got per school night, and it was rounded to the nearest hour, and the frequency chart shows the results. So when I look at this, it says the frequency means that there were 2 times that this happened. So there were 2 students that said they got 4 hours of sleep. There were 5 students that said they got 5 hours of sleep, etc. So if I wanted to list this out, I would put 4, 4. There's my 2 students that said they got 4 hours of sleep. Then there were 5 students that said they got 5 hours of sleep. So then I would list out 5. And then there were 7 students that said they got 6 hours of sleep, and I would continue that. I'm not going to write it all out, but you guys get the idea. So when we're looking for the 28th percentile, we want to find that value in the data set, and these are our data values. we want to find the value in the data set so that 28% of the data lies below that value. So we're going to use our formula to find our position. So we have I, and then 28 over 100. K in this case is 28 because that's my percentile. And N is going to be 50 because we have 50 data values. So when I put it in the formula, this is going to be 51 because remember this value in the parentheses is N plus 1. So when I multiply that out, I'm going to get 14.28, which means I want to find the average of the 14th and the 15th position. I'm going to add in another column here, the cumulative frequency. Okay, so up to this point we have 2. Then when I add in the 5, that gives me a total of 7 values. Then when I add in 7, that gives me 14. So this right here, when I go to list out my 6s, that means my 6 is going to be in the 14th position because I have 2 4s, then I have 5 5s, and then I list out 7 6s. So 6 is going to be my 14th position. So the 15th position is going to be 7. Now when I take the average of those, that will give me a 28th percentile of 6.5. Because I would take 6 plus 7 and then divide by 2, that gives me 6.5. This method is only going to work if your frequency chart has single values in each of your bins. If this was a range of values, say between 4 and 8 or between 5 and 10 or something like that, you wouldn't know unless the individual data values were given to you what those values were that lie on that interval. Because it's individual values, we know what they are. So keep that in mind, that you can only use this trick if those are single values in your bins. Okay, now we're going to find the median. Okay, so the median is going to be the 50th percentile, which means I'm going to take and use my formula where K is 50 and of course N is 50. So I have 50 over 100 times 51. That's going to give me 25.5, which means I need to find the average of the 25th and the 26th position. So when I come up here and I find the 25th and the 26th position, I'm going to go ahead and keep going through to find the rest of my cumulative frequencies. So we stopped at 14. If I add 12, that's going to give me 26. So what that tells me is the 25th and the 26th position is definitely both going to be a 7. So then the median is going to be 7. Because the 15th through the 26th position lies on that interval. Okay, the third quartile, that's going to be the 75th percentile, and it's 50 again. So when I use my formula to find the position, I'm going to take 75 over 100 and times it by 51. That's going to give me 38.25. So I need to find the average of the 38th and 39th position. So if I come up here and look back here and I finish counting my cumulative frequencies, if I add 26 and 14, that gives me 40. So I know that my 38th and 39th value lies on this interval, and they're both going to be 8s. So that means if I take the average of 8 and 8, I'm going to get 8. So in the next couple of examples, we're going to work backwards. What we're going to do is we're going to find the percentile if we're given the data value. In the previous examples, we were told the percentage and we wanted to find that data value. Now we're doing it in reverse. We want to find the percentage given the data value. So here's the formula that we want to use for that. And then you always round to the nearest integer. So now the x's and the y's in this problem are defined down here. So the x represents the number of data values counting from the minimum value up to, but not including the data value that you're trying to find that percentile for. Okay, and then the y value represents if you have any repeats. So if you have, let's say the value you're looking for is 7 and you have 3 7s in that data list, then y is going to be 3. It tells you the number of repeats for that data value that you're looking for. Now, if there are no repeats, then you just put down that y is 1. And then, of course, n is the total number of data values. So in the example, it has that there are 29 data values here. And this is for ages of Academy Award-winning Best Actors. And it says that they already ordered the data for us, which is nice. We want to find the percentile for the data value of 58. Now, if these weren't sorted, we would have to sort first. So I'm looking for 58 here. Because 58 is only listed once here, y is going to be 1. Now, what x represents is the number of data values less than 58. So we need to count that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that means x is going to be 18. So now when I plug this into our formula, remember our formula is up here, we have x plus 0.5y over n, then we multiply it by 100 and round to the nearest percentage. Okay, so in this case we have 18 plus 0.5 times 1, which is 0.5, over, we're told that there are 29 data values, so n is 29. So when I put that in on the calculator, we should get 63.80. Now remember, we always round to the nearest integer, so in this case, that would give me the 64th percentile. If I look at the number 58 in this list, there's 64% of data values that lie beneath 58 or less than 58. Now let's do the same thing for 25. Okay, so when I look at 25 in our list, there's only 125 there. So again, we have no repeats, which is nice. Y is 1. We want to count, to figure out what x is, we want to count the number of values that are less than 25, which is 1, 2, 3. So now when I go ahead and put this into our formula, I get 3 plus, and then 0.5 times y, and y is 1, so that's 0.5 over 29. And then I have to take that answer and multiply by 100. So when I do that, I get 12.07. And we always want to round to the nearest percent or the nearest whole number. So that would be the 12th percentile, which means there's about 12% of the data values lie beneath 25 or less than 25. So in the last two examples, we are going to interpret percentiles. So the first example says, on a timed math test, the first quartile for time it took to finish the exam was 35 minutes. We're going to interpret the first quartile in the context of this situation. So this is saying that Q1, which we know is the 25th percentile, is 35 minutes. That means if I listed all the data values in increasing order from smallest to largest, we know that 25% of the students finished in less time than 35 minutes. because remember, percentile is the values that are less than 35. The other way that we could say this, so let's write this down as option 1. We could also flip it in a different direction. Remember, if I look at it like a number line, if I split it here, where this is the 25th percentile, that means 25 goes this way, which means 75 is above. So I could also write it as 75% of the students finished the exam in 35 minutes or more. It's from here and up. So you could write it either way. Let's look at the next example. It says, at a community college, it was found that the 30th percentile of credit units that students are enrolled for is 7 units. So it's saying that the 30th percentile is 7 credits. Interpret the 30th percentile in the context of this situation. So because it's the 30th percentile, I could say it one of two ways. I could say 30% of students enrolled with less than 7 credits. Or if I look at the complement of that, if I break it up, if this is 30%, then this has got to be 70%. So I could also say 70% of students enrolled with 7 or more credits. It's really important to know what your quartile represents in terms of the units. Like 7 credits, well, they use the word units in here, or credit units, but it's the same thing. It's really important, that way you can identify what it is that you're talking about. So make sure if you're interpreting this in the context of a problem that you are labeling your units. So in this section, we covered measures of position, which included the special measures of position, which we talked about with the quartiles and the median. When we get into the next section, we're going to use those values to make box and whisker plots.